In this lesson, we will learn simple acid-base calculations. We are given a hydronium concentration, H3O plus, of 1.3 times 10 to the negative 3 molarity, or moles per liter. So what is the pH? How do we calculate pH in this instance? pH is simply the negative log of the concentration. So the negative log of the concentration of H3O plus equals the negative log, in this case, of 1.3 times 10 to the negative 3. So let's punch that into our calculators. In my case, in my app in my smartphone. So the negative log, 1.3 times 10 to the negative 3. And the result is 2.886, or rounded to 2.9 pH. So we are given a pOH of 2.3. What is the pH? How do we calculate the pH? Okay, we know that the pH plus the pOH equals 14. So 14 minus the pOH equals the pH. And that would be 14 minus 2.3 equals a pH of 11.7. So here's an interesting problem. So you are given a pOH of 4.2. And the question is, what is the concentration of hydroxide ions? So hydroxide is OH minus. So how do we find the concentration of hydroxide given the pOH? So what we know is the concentration of OH minus equals 10 to the negative pOH power. So let's plug those numbers into our calculator. So 10 to the negative 4.2 equals 6.31 times 10 to the negative 5th moles per liter. And that is the final answer. So that is the concentration of hydroxide. So let's try another problem. So we are given the concentration of hydroxide of 2.7 times 10 to the negative 4. And what is the pH? So we're given the concentration of hydroxide, and we want to find the pH. So first, we'll find the pOH. So that'll be the first step. So pOH equals the negative log of the concentration of hydroxide equals the negative log of 2.7 times 10 to the negative 4. That equals 3.57. So that's the pOH. So now that we have the pOH, we know that 14 minus the pOH equals the pH. So 14 minus 3.57 equals 10.43, and that equals the pH. And that is our final answer. So let's do another. So we know that the Ka, or the acid dissociation constant of a solution, equals 1.7 times 10 to the negative 4th molarity. So what is the pKa? Now pKa, like the pH, is the negative log of the concentration. So let's write that down. pKa equals the negative log of Ka equals the negative log of 1.7 times 10 to the negative 4th power. Let's punch that into our calculators. So the negative log of 1.7 times 10 to the negative 4th. And the final answer is pKa equals 3.77. And that is the result. Okay, next, we're given an H3O plus, or the hydronium concentration of 7.2 times 10 to the negative 3 molarity. Remember, concentrations are always moles per liter. So what is the pH? How do we calculate the pH? Now remember, the pH equals the negative log of the concentration of hydronium, the negative log of H3O plus, equals the negative log of 7.2 times 10 to the negative 3. So we'll punch that in. Negative log 7.2 times 10 to the negative 3. And the result is 2.143. And let's circle that. Okay. Let's do another. So we are given a pKa of 3.23. What is the Ka? How do we calculate the Ka? So let's think about this. So the Ka equals 10 to the negative pKa power and we plug those numbers in. 10 to the minus 3.23 equals 5.89 times 10 to the negative 4th molarity. So let's do our final problem. You're given a pKb of 2.46. And you are told you must use the Kw value or the dissociation constant of water to calculate the Ka. So our goal is to calculate the Ka using the Kw value. So first, because we're given the pKb, we want to calculate the Kb. So Kb equals 10 to the negative pKb equals 10 to the negative 2.46 power equals 3.47 times 10 to the negative 3. So that is our Kb. Now we know that Kw, or the dissociation constant of water, is 1.011 times 10 to the negative 14. And we know that Kw divided by Kb equals the Ka. So let's do this calculation. So it's 1.011 times 10 to the negative 14 over 3.47 times 10 to the negative 3. Let's punch this into our calculators. And we come up with a final result for our Ka equals 2.91 times 10 to the negative 12th molarity, or moles per liter. And that's our final answer. Okay, good. Now we want to review some formulas that are going to be necessary to do these calculations. So let's list off important formulas for doing acid-base calculations. So formulas. We'll start off with Kw formula. So Kw, which is the equilibrium constant for water. It's the concentration of OH minus times the concentration of hydronium ions, H3O plus, and that equals 1.011, or often rounded just to 1 times 10 to the negative 14th. Okay, pKa. pKa equals the negative log of Ka. And Ka equals 10 to the negative pKa power. We call this the acid dissociation constant. pKb. pKb, which is the base dissociation constant, equals the negative log of Kb. And the same way as Ka, the Kb equals 10 to the negative pKb. And that's the base dissociation constant. Now the pH. pH is the negative log of the concentration of hydrogen ions. So pH equals the negative log of H3O, or hydronium ion concentration, and that is the pH. Now the pOH. pOH equals the negative log of the hydroxide concentration, which is OH minus. And then the concentration of H3O plus, or hydronium ions, equals 10 to the negative pH. And the concentration of OH minus equals 10 to the negative pOH power. And then finally, the pH plus the pOH equals 14. Now it's important to have at least these formulas memorized. And this was a fun video to make, and I hope to see you in the future.